Good evening, students. Welcome to Sankalp Learning Classes. Today we are discussing important questions from the chapter Magnetic Effects of Electric Current. The theoretical part of this chapter already we have studied in the previous classes. So today we are discussing only important question answer. So how we are discussing the important question answer? So first we are discussing MCQs. After that 1 mark and short answer as well as long answer questions like 4 mark questions, 2 mark questions, like that we are discussing in this chapter. So just recall what you learnt in this chapter. Properties of the magnets. So mainly properties of the bar magnet. So or magnetic field lines. What are the properties of the magnetic field lines? And the magnetic field, what are the characteristics of the magnetic field which is produced when the uh, produced around the current carrying conductor, that also we have studied, and the different laws like Fleming's left hand rule as well as right hand thumb rule. So these all things we have studied, and then at last domestic electric circuit that we studied in this chapter. Okay, let us start with the first question. The magnetic field lines inside a solenoid are in the form of parallel straight lines. The reason for this is magnetic field inside the solenoid is option A very high, option B uniform, option C 0, option D produced by electric current. Yes, what do you mean by solenoid? Solenoid which act as when the current carrying conductor which is in a coil like this, so which is connected to the electric cell, it is called as a solenoid, right? So which act as a bar magnet. Here the magnetic field lines inside a solenoid, inside this solenoid, are in the form of parallel lines. So the magnet, it act as a bar magnet. The solenoid act, when current passes through this, it act as a bar magnet. And the reason for this, the magnetic field lines field inside the solenoid is, so that is option B uniform. The magnetic field lines, the magnetic field inside the solenoid, that is uniform. Okay, option B is the correct answer. Second question, observe the diagram. The magnetic poles represented by P and Q respectively are, what is P and what is Q here? Option A south S and south S, both are S and S. B north N and south S. Option C north N and north N, here N and N. And option D south S and north N. Here just see the magnetic field lines, how they are extended. They are extended like this, so you can see the arrow mark like this. So always the magnetic field lines, they extend from north pole to the south pole. Okay, so see here the magnetic field lines are like this. So the direction is here, here this is north and this is south, north to south, alva here. So what is the correct answer here? The magnetic field lines, what is P and what is Q? North to south, right? So the magnetic field lines, they extend from north to south. So here what is the correct answer? Option A south S and south S, and option B north N and south S. Then option C north N and N. Here the correct answer is option A south S and S. So this is also south. This is also south. Sorry. Option A is the correct answer. Next question. Which of the following correctly describes the magnetic field near a long straight wire? Which of the following correctly describes the magnetic field near a long straight wire? The field consists of straight lines perpendicular to the wire. The field consists of straight lines parallel to the wire. The field consists of radial lines originating from the wire. The field consists of concentric circles centered on the wire. Here, which of the following correctly describes the magnetic field near a long straight wire? Here, this is a long straight wire, and so the magnetic field, so it will be like this when the current passes through this. The correct answer is the field consists of concentric circles centered on the wire. Option D is the correct answer. Next question. At the time of short circuit, the current in the circuit, option A, reduces substantially. Option B, does not change, increases heavily, vary, vary continuously. At the time of short circuit means sometimes it happens when the many appliances are attached to the single sockets, or when there is a damage in the wire. So these all may cause the short circuit. So at the time of short circuit, the current in the circuit reduces substantially, does not change, increases heavily, vary continuously. Here, the correct answer is increases heavily. Option C is the correct answer. That is, increases heavily. Next question. State whether the following statements are true or false. Okay. The field at the center of long solenoid carrying current will be parallel straight lines. B. A wire with green insulation is usually the live wire of an electric supply. Here, see the A. You have to state whether it is true or false. Okay. The field at the center of a long solenoid carrying current will be parallel straight lines. Yes, it is true. Then a wire with a green insulation is usually the live wire of an electric supply. Okay. But the wire with green insulation, which is not a live wire, which is a earth wire. Earth wire, and the live wire with red insulation. Okay, here the red wire that will be with which insulation? That will be with red wire that represents the live wire. Okay, so B is the wrong one, that is false. Next question. Magnetic field is a quantity that has both a dash and dash. Magnitude and direction, only magnitude, direction, none of this. So the magnetic field, so that contains, magnetic field is a quantity that has both magnitude and direction. Option A, which has both magnitude and direction. Option A is the correct answer. Next question. Electric current through a metallic conductor produces a dash around it. When just imagine this is the electric wire, and has which has a electric current supply. So when it passes through the wire, it produces a dash around it. What is produced around this conductor, metallic conductor? It produces the magnetic field. What it produces? It produces the magnetic field. Okay, so it can be asked for 1 mark question as a 1 mark question. Magnetic field. Next question. In our country, the potential difference between two wires is option A 220 volt, option B 240 volt, option C 225 volt, option D 230 volt. In our country, the potential difference between two wire is, so what is the correct answer here? 220 volt, 240 volt, 225, 230. So that is 220 volt. Option A, 220 volt will be the, in our country, the potential difference between the two wires. So that is 220 volt. Option A. Next question. In right hand thumb rule, thumb represents magnetic field, direction of current flow, direction of the magnetic field, none of this. Here, the right hand thumb rule, the right hand thumb rule. So just imagine this is the current carrying conductor, and so these are the uh this is the remaining fingers, and just imagine this is the thumb. Okay, current is flowing in this direction. So here this thumb represents the direction of the current flow. It represents the, when you hold like this thumb represents the direction of the current, and the remaining these four fingers which are around the conductor, so that represents the direction of the magnetic field. Okay, here, so the correct answer is option B, the direction of the current flow. Next question. According to Fleming's left hand thumb rule, thumb represents direction of the magnetic field, direction of the current, force acting on conductor, none of these. Here, the left hand, Fleming's left hand rule. So when these three finger, you should handle these three fingers, they should be perpendicular each other. Three fingers should be perpendicular to each other. So here, what they are asking, what is the thumb represents here? The middle finger represents the direction of the magnetic field, and thumb indicate, sorry, the middle finger that direction of the current, and the index finger represents the magnetic field, and here the thumb represents the force. So that is the option, force acting on a conductor. Option C is the correct answer. Okay, so here, so this is what the Fleming's left hand thumb rule. Okay, very important. So till now, students, we have discussed the some multiple choice question from this chapter. Let us discuss the some short answer as well as long answer questions from this chapter. Okay. Yes. Let us start with the first question. List two methods of producing magnetic fields. So how we can produce the magnetic fields? Here we can produce the magnetic fields by using a magnet. That may be a different types, horseshoe magnet or a different bar magnet. So they needle magnets. So these are the magnets which produce the magnetic field and use an electric current. When electric current passes through the metallic wire, it produces the magnetic field. So these are the two methods of producing the magnetic field. It can be asked as a 1 mark question. Okay. So this question may ask as a 1 mark question. Next question. When does an electric short circuit occur? So very important topic, that is the electric short circuit. When does an electric short circuit occur? Here, electric short circuit, the insulation of wires damaged. When the insulation of the wires damaged, there is a fault in the electric appliances. So if it is asked as a 1 mark question, so this much is enough. The insulation of the wires damaged, or there is a fault in electrical appliances. So these are the different methods of reason for the electric short circuit. Okay. Next question. Observe the figure and mention the direction of the force acting on the current carrying conductor AB. Name the rule that helped you find the direction of the force. Here, observe the figure. So, I hope you know this experiment, and mention the direction of the force acting on the current carrying conductor AB. So, this is the current carrying conductor AB. So, this is a current carrying conductor. Current is flowing in this direction. Okay, so this is the direction of the current, and you have to find out the force acting on the current carrying conductor. So in which direction the force is acting on this current carrying conductor, and which rule you have to use to find this force. So that is the which rule you will use for this. This is the Fleming's left hand rule. Fleming Fleming's left hand rule. Okay, Fleming's left hand rule. So here already you know that the what these three fingers represent. Here thumb represents the direction of the force acting on this, and the index finger represents the magnetic field, and the middle finger that represents the direction of the current. Here the direction of the current is like this, in this direction, and the force acting, so the thumb just hold like this and find out how the thumb is, in which direction the thumb is. So here the rod is displaced towards the left. Here how the AB rod that displays towards the left. Okay, so which rule we have used for this? So that is Fleming's left hand rule. Very importantly, Fleming's left hand rule we have used to find out this. Okay, next question. What is solenoid? Write the properties of magnetic field lines formed around a current carrying solenoid. Here the question is what is solenoid, and you have to write the properties of the magnetic field lines which are formed around the current carrying solenoid. Next question. B. What is alternating current? This topic is removed now. And electric appliances having metallic body are connected to earth wire. Why? Okay, so this alternate current and motors, AC motor, DC motor, so these all topics are removed, reduced from your syllabus, so no need to read this. Let us see the first one answer. A solenoid is a coil of wire designed to create a magnetic field when an electric current passes through it. The solenoid is a coil of wire. So it looks like this, coil of wire. create a magnetic field when electric current passes through this. So which create the magnetic field when it receives the electric current, often used in electromagnets and electromechanical devices. Okay, so this is the answer. What is solenoid? Very important question. Second question, that is, write the properties of magnetic field lines formed around a current carrying solenoid. What are the properties? The solenoid which act as a bar magnet, and the magnetic field lines which are having the same properties of the magnetic field lines produced around the bar magnet. The field lines emerge from the north pole and merge at the south pole inside the bar magnet. The direction of field lines is from its south pole to its north pole. Then the magnetic field lines are closed curves. Magnetic field lines never intersect each other. So the magnetic field lines which are produced, they never intersect each other. So these are the some properties of the magnetic field lines produced around the bar magnet. Next question. What is alternating current? Electric appliances having metallic body are connected to earth wire. Why? Here, alternating current, just for your knowledge purpose, is an electric current that reverses the direction periodically as opposed to the direction of current, direct current, that is DC, which flows in one constant direction. Then the metallic body is connected to the earth wire, which provides a low resistance conducting path for the current. Means it ensures that leakage of current to the metallic body of the appliances keep its potential to that of the earth, and the user may not get severe shock or any damage. So this earth wire that removes the uh, extra current, which is the leakage current from the metallic body to the earth. So it is helpful for, it is helping for it is useful for the users, which may prevent them from the electric shock. Okay, so this is the answer for the first question. So it can be, so this first question, this is the 2 mark question, this is 2 mark question, and this is also 2 mark question. Okay, next question. What are the reasons occurring overload in an electric circuit? What are the reasons for the overload in an electric circuit? Here, overloading can occur when the live wire and the neutral wire come into direct contact. When these live wire and the, so that is having the red insulation, and the neutral wire that is having the black insulation, come into direct contact. Here, this occurs when the insulation of wires is damaged, there is a fault in the appliances. Overloading can also occur due to the accidental hike in the supply voltage. So, sudden voltage when it is increased in a circuit, that also cause the overloading. So, this is very important question. Repeatedly, this question is asked many times. Okay. What are the reasons for occurring the overload in an electric circuit? Please note down the answer. Okay, next question. List the properties of magnetic field due to the flow of electric current in a solenoid. Here, list the properties of the magnetic field. What are the properties of the magnetic field when the current flowing through the solenoid? What are the two methods of increasing magnetic field in solenoid? How we can increase the magnetic field? So this can be asked as a 3-mark question. Okay. So very important. What are the properties of the magnetic field due to the flow of electric current here? It is similar to the bar magnet. The magnetic field is similar to the bar magnet, and it has the solenoid. Looks like this. It has north and south poles. Just imagine this is the north pole and this is the south poles. Can magnetize other materials. So when the non-magnetic materials are kept inside this, so they it can be converted into magnetized material. And uniform magnetic field at the center. The magnetic field, so that is uniform inside the center, and which is having the magnetic field lines also there. So these are the some properties of the magnetic field lines. Then what are the two methods of increasing the magnetic field in the solenoid? How we can increase the magnetic field inside the solenoid? First method is by increasing the number of turns in the coil. Here, by increasing the number of turns. So if you increase the number of turns, the magnetic field also increases. Then more turns result in a stronger magnetic field for the same current. And second method is increasing the current through the coil. A higher current produces a stronger magnetic field for the same number of turns. Here, when you increase the rate of current flow, so then there is a chance of increase in the strong there is a chance of producing the strong magnetic field. Okay, so that is the correct answer. Next question. Magnetic field lines do not intersect each other. Why? One of the very important question. So this is 1-mark question. Magnetic field lines do not intersect each other. Why? What is the answer for this question? Magnetic field lines do not intersect each other because if they did, so just imagine this is the bar magnet, north and south poles. Okay, so these magnetic field lines, so they will never intersect each other. So they will never intersect like this. Okay. What is the reason behind this? If they did, it would mean that the point of intersection, there would be a two different direction. So these magnetic fields have the magnetic field lines, they have the two different direction. Means here north and south, but here there will be a north or south. So they are intersecting like that. So it would be two different direction for the magnetic field, which is not possible. Each point in a magnetic field has only one direction in the field, so the lines always remain separate and never cross. So note down the answer. Next question. What are the functions of earth wire? It is necessary to connect electric appliances having metallic body to the earth wire in the domestic circuit. Why? Explain. So see the question. What are the functions of the earth wire? That is 1 mark. It is necessary to connect electric appliances having metallic body to the earth wire in the domestic circuit. Why? Explain. So totally this is 3-mark question. Okay. What are the functions of the earth wire here? The functions of earth wire is to provide a safe path for electrical current to flow into a ground in case of fault, such as short circuit or insulation failure. So, which provide the safe path for the electrical current flow. Then, this helps to prevent the electric shock, reduces the risk of electrical fires, and ensures the safety of both electrical appliances and users. So here, so for this reason, it is very important to connect the metallic appliances, which are metallic electric appliances, so to the earth wire, which is helpful for the users and which protect them from the electric shock and reduces the risk of electrical fires and ensures the safety of both electrical appliances and the users. So this is the correct answer. Next question. How does overload and short circuit occur in an electric circuit? Explain. What is the function of fuse during this situation? Mention the two properties of magnetic field lines. Here, first, how does overload and short circuit occur in an electric circuit? Explain. What is the function of fuse during this situation? That is 2-mark question, and this is also 2-mark question, totally 4-mark question. Yes, let us see the answer for the first question. Overloading occurs when too many electrical devices are connected to a circuit, drawing more current than the circuit is designed to handle. They draw the more current where the circuit which is designed to handle. This excessive current can cause the overheating of the wiring and potentially lead to the electrical fires. And overloading can also occur due to accidental hike in the supply voltage, or overloading can also occur due to the accidental hike in the supply voltage. So these are the some methods, reasons for the overloading. Then second question is, what is the function of the fuse during this situation? What is the function of the fuse during this situation? Here, the fuse that uh, prevent the use of an electric fuse prevents the electric circuit and the appliances from the possible damage by stopping the flow of unduly high electric current. So that prevents the electric circuit or electric damage. The joule heating that takes place in the fuse melts to break the electric circuit. That fuse breakdown and that also break the electric circuit, and that will be helpful to prevent the electric appliances. Then what is a short circuit? Sorry, here short circuit. It occurs overloading and short circuit. Circuit occurs when a direct connection is made between the 2 points in a circuit with different electrical potentials bypassing the intended load. Okay, this creates a path of very low resistance, allowing the large amount of current to flow suddenly, which can also cause the overheating, damage to the components, and electrical fire. So please note down the answer. Next question. Suggest any two measures to avoid the overloading in our domestic circuits. So very importantly, this overloading, short circuit, and yeah, what is the function of the earth wire? These all are very important for your exam. Okay. Here, avoid the connecting too many appliances and use of a fuse. So these are the two methods which prevent the suggest any two measures to avoid the overloading in a domestic circuit. So these are the two methods which prevent the overloading in a circuit. What does the thumb indicate in the right hand thumb rule? What does the thumb indicate in the right hand thumb rule? So in the right hand thumb rule, yes, this is the right hand thumb rule. So here, when this is the current carrying conductor, this is the conductor. When you hold this conductor in a right hand, so these four fingers, these one, two, three, four fingers, they represents the magnetic field, direction of the magnetic field which are formed around the this current carrying conductor, and this thumb that represents the electric current. The thumb that is representing the electric current. Thumb indicate the direction of the electric current. Okay. Next question. An electric oven of 2 kilowatt power rating is operated in a domestic electric circuit, that is 220 volt, that has current rating 5 ampere. What is the result you expect? Explain. Here, what is the power? So that is 2000 watt and operated in an electric circuit. So that has the current A. So what is the current I? That is equal to 5 ampere. And what is the volt? V is equal to 220 volt. Okay. Here you have to apply the formula P is equal to V into I. Here P is equal to V into I formula. So here just I is equal to, what is the current uh, required? That is I is equal to P by V. So P is 2000 divided by voltage is 220. So I will cancel this. 2 ones are 200. 9.09. Okay. Here the current will be 9 ampere. The current drawn by this electric oven is 9 ampere. So when the power of 2000 watt and voltage 220 volt current is there, then the current drawn is 9, electric current flow is 9 ampere, whereas the fuse in the circuit is only 5 ampere capacity. So when a high current of 9 ampere flows through the fuse, the fuse wire will get heated too much and melt and break down the circuit. So here there is a breakdown of the circuit takes place due to the high electric current, because this fuse is uh, designed to handle only 5 ampere current, but this electric oven, so that draws the 9 ampere current. Okay, note down the sum. Next question. What precautions should be taken to avoid the overloading of domestic electric circuits? What are the precautions we should take? Each appliances has separate switch to on and off the flow of current through it. Each appliances has a separate switch to on and off the flow of current through it. The fuse, the use of an electric fuse prevents the electric circuit and the appliances from the possible damage by stopping the flow of unduly high electric current. And third one, we should not connect too many appliances to single socket to prevent the overloading. These are the some methods that are used to prevent the overloading in a circuit. So note down the answer. Question is, what are the precautions should be taken to avoid the overloading of domestic electric circuits. Next question. How does a solenoid behave like a magnet? How does solenoid behave like a magnet? Can you determine the north and south poles of current carrying solenoid with the help of bar magnet? Explain. So when the current passes through the solenoid, it acts as a magnet. How we can determine the south and north pole of the solenoid? Okay, here one end of the solenoid behaves as a magnet north pole while the other behaves as a south pole. The field lines inside the solenoid are in the form of parallel straight lines. This indicates that the magnetic field is the same at the points inside the solenoid. As so here I will show the diagram here. So this is the current carrying solenoid and the field lines of the magnetic fields through the current carrying solenoid. Okay, so here magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron. When placed inside the coil, the magnet so formed is called as a electromagnet. So this is the diagram. Next question. When is the force experienced by current carrying conductor placed in a magnetic field largest? When is the force experienced by current carrying conductor placed in a magnetic field is largest? So you have to apply the you should know the Fleming's left hand rule. So in that rule, so what he explains, the direction of the magnetic field and flow of electric current are mutually perpendicular, then the force experienced by a current carrying conductor in a magnetic field is largest. Here, the direction of magnetic field and flow of the electric current are mutually perpendicular. So, when they are perpendicular to each other, the force experienced by a current carrying conductor in a magnetic field is largest. Okay, this is the correct answer. Next question. State the rule to determine the direction of a magnetic field produced around a state conductor carrying current. Force experienced by a current carrying state conductor placed in a magnetic field which is perpendicular to it. And here, first one. So read the sentence properly. Magnetic field produced around state conductor carrying current. So here, right hand thumb rule. So here the right hand thumb rule is used. If the current carrying conductor is held in a state held in the right hand, such as thumb points in the direction of the current, then the direction of the curve, the fingers will be given in the direction of the magnetic field. Next one, Fleming's left hand rule. The second one is force experienced by a current carrying straight conductor, so that placed in a magnetic field which is perpendicular to it, that is the Fleming's left hand rule, where the stretch the forefinger, the central finger of right hand mutually perpendicular to each other. If the forefinger points in the direction of the magnetic field, the central finger in the direction of the current, and then the thumb points in the direction of the force in the conductor. When does an electric short circuit occur? So this is the most repeated question. So very important question. When does an electric short circuit occur? Okay. Overloading can occur when the live wire and the natural wire come into direct contact. In such situation, the current in the circuit abruptly increase. This is called as a short circuiting. So this short circuit that may be also caused by when the two wires when they are damaged, when they are come into contact. So that is the reason for the electric short circuit. The current so that during this electric short circuit, the current that flows very fastly, very heavily in the electric wire. Note down the answer. Next question. What is the function of an earth wire? Why it is necessary to connect the earth metallic necessary to earth metallic appliances? So earth wire to metallic appliances. Here, this is used as a safety measure, especially for those appliances that have metallic body. For example, electric press, toaster, table fan, refrigerator, etc. The metallic body is connected to the earth wire, which provides the low resistance conducting path for the current. Thus, earth wire ensures the any leakage of current to the metallic body of the appliances keeps its potential to that of the earth, and user may not get severe electric shock. So this is what the reason why the all metallic appliances should contain the should connect with the earth wire. Next question. Explain the right hand thumb rule. Here you have to explain the what is right hand thumb rule with diagram here. The right hand thumb rule states that if you hold a current carrying wire in a right hand, if you hold this current carrying conductor in a right hand, so like this, the thumb indicates the thumb pointing towards the direction of the current, and the remaining fingers which are holding the current carrying conductor, that represents the magnetic field or direction of the magnetic field. Okay, so this is the diagram. Next question. Explain the Fleming's left hand rule. Here, the Fleming's left hand rule is used to determine the direction of the force acting on a current carrying conductor in a magnetic field. Here, stretch out your left hand's thumbs, index finger, middle finger, so they are perpendicular to each other. So like this, the index finger points in the direction of the magnetic field. This represents the direction of the magnetic field, and the middle finger represents the direction of the current, and the thumb that points in the direction of the force acting on the conductor. Okay, so this is the right hand sorry left hand rule, Fleming's left hand rule. So very important. So which finger, so what it represents, so that is very important. Next question. List the properties of magnetic field lines. Very important question. So this is 2 mark question. 2 mark question. List the properties of magnetic field lines. Here, what are the properties of magnetic field lines? Magnetic field lines are continuous curves that are formed closed loops. Just imagine this is the bar magnet. So these magnetic field lines, they are closed loops like this. They originate from the North Pole and end at the South Pole. North Pole, and this is the South Pole. So like this, end at the South Pole. Magnetic field lines are more crowded near the poles. They are more near the poles like this. They are more crowded near the poles where the magnetic field is stronger, where the magnetic field lines are crowded, where the magnetic field is stronger. Magnetic field lines never cross each other, they never intersect each other like this. So just imagine this is the magnetic field lines, so they will never intersect each other. So these magnetic field lines never cross each other. Next question. Is it possible to connect 1320 watt refrigerator to a 5 ampere rated plug in 220 volt household circuit? Explain the reason for your answer. Here, power that is 1320 watt and current I is equal to 5 ampere and V is equal to 220 volt. So this is the given data. Here, apply the formula P is equal to V into I formula. Here I is equal to P by V as same we did in the last sum. Here P is 1320 divided by 220. So cancel 2 ones are 2 ones are 2 6 are 2 6 are 11 6. So I is equal to 6 ampere. But here the current given is, so the current flowing through the circuit, that is 5 ampere rated plug. So 5 ampere is not enough. No, it is not possible to connect 1320 watt refrigerator to a 220 volt household electric circuit with 5 ampere fuse because fuse may blow. Okay, so this is the answer. Next question. Draw a magnetic field lines around the bar magnet. You should draw the diagram of the magnetic field lines around the bar magnet. So the diagram should be like this. So you should draw the bar magnet and mention the north and south poles. And you should draw the magnetic field lines and you should mention the direction of the magnetic field, and where near the pole it is very high. Near the magnetic poles, the magnetic field lines are more and the magnetic field is also more. So like this you should draw the diagram. Okay. So dear students, so till now we have discussed very important questions from this chapter, and in the last year, compared to the last year, many topics from this chapter, very important topics, were reduced. For example, AC motor, DC motor. So these all topics are reduced. So we are not discussing that topic. So we'll end the session here. I will continue in the next class. Okay, thank you. I hope it will be useful for your board exam.